Okay, good morning, folks. What questions do you guys have today?
Could we look at number 19?
Sure. Okay, so draw a picture first because that's always helpful. I've got y squared minus 3x equals 9, so that's going to be a horizontal parabola. We're doing everything in terms of y, so I'm just going to make this my y-axis and this my x-axis. So it turns out that it's actually a vertical parabola, but we're just going to think of a variable as y, input variable y, output variable x. So that's y squared minus 9 equals 3x. And so y squared minus 9 over 3 equals x. So that's going to look something like this. And then x equals y plus 3. Going to look something like that. I need to figure out where to start my integration and where to end my integration in terms of the y values. So I need to figure out where these points cross. So I need to set up, well, if I've solved for x here, I need to set up y squared minus 9 over 3 equals, if I've solved for x with this one, I get x equals 3 plus y. So I want to know where the graph of the line, which is this line, then the graph of the parabola, which is this parabola here, they're equal. That's going to tell me where the points cross. So I solve this. So I get y squared over 3 equals y plus 6. Move stuff over here. Y squared, we'll multiply everything by 3 minus 3y plus 18 equals 0 minus 18. Then I can factor that. I can factor that as y minus 6, y plus 3 equals 0. So y equals 6 or y equals minus 3. So it's going to tell me that this happens at y equals minus 3. This is at y equals 6. Okay. It looks like we only need one integral. So I'm going to pick this one. And it's going to go from minus 3 up to 6. Let's draw in the rectangle first. So I'm going to draw in my representative rectangle. So this is at a y value because I've got my y-axis is my y-axis is the horizontal axis. This point is going to be at y comma 3 plus y because that's on the line, right? That's the 3 plus y is the output of that. And this one's going to be at y comma y squared over 3 minus 3 because that's on the parabola. Okay. So the height of the rectangle is going to be 3 plus y minus y squared over 3 minus 3. Right. The width is dy. So I'm going to go the integral from -3 up to 6. We're going to put that, oh, I don't want the dx one, I want this one with the dy, right? -3 up to 6 with the dy, and then the y's are going to be 3 plus y minus y to the second over 3 minus 3. Maybe it wants me to simplify that, but I'm going to try it here. So we start with that, and then what's the other part? Oh, now we actually have to find the integral. Okay. So questions on the setup so far? Okay, so let's actually integrate that. And I can put this stuff together a little bit. So I've got a minus y squared over 3, got a plus a y, and then I've got a plus 6 dy after I combine those two. So this is going to equal, well, I take the antiderivative of that, and I get minus y cubed over 9 plus y squared over 2 plus 6y evaluated at -3 and 6. It's going to be minus 216 over 9 plus 36 over 2 plus 36. And then it's going to be minus 27 over 9, because that negative cubed becomes negative still, and then I have 4 negative signs, plus 9 over 2 minus 18. And that's going to be 24 with a minus sign, plus 18, plus 36, minus 3 plus 4.5 minus 18. So that's going to be minus 7.5 plus an 18. So that's going to be 72 minus 24 minus 7.5. It's going to be 48 minus 7.5, 40.5. 81 halves. Hopefully I did my arithmetic right. Okay. So what questions do we have on that one?
I was just struggling to set it up a little bit. Thank you.
Okay. Other things you guys want to talk about today?
Can we look at 25? I think the wording and like the problems is kind of like screwing me up.
Okay. So we need to draw the picture here. So we're going to be in the first quadrant. Okay, so we'll start with that. We're bounded by the y-axis on the left, so I'm going to draw my bounds. So it's going to be to the right of that yellow, green dotted line. It's going to be below the line, y equals x over 16, which is a shallow sloped line. So it's going to be below that. It's going to be above left by oh sorry, it's below by this line. That's good because it's not much below it. It's bounded above and left by the curve 3 plus the square root of x. So there's 3, there's the square root of x. So that's above and to the left. So that's that boundary, that's that boundary, that's that boundary right through here. And then above and right by the curve 4 over the square root of x, which is going to look something like this. So it's going to be this weird region here. I'm going to do that in purple because my boundaries are. This is y equals 4 over the square root of x. This is y equals 3 plus the square root of x. This is y equals x over 16. This is x equals 0. So those are the 4 sides of my shape. We good with that?
Yeah.
Okay. So as I look at this, if I'm going to do vertical rectangles in here, those are going to have a different top function than these over here. So I'm going to have to split this into 2 pieces where I integrate from 0 to whatever, and then from whatever to whatever again. I need to figure out what this point is, what this point is. I know that this guy starts at 0, so we can start there. But I need to figure out what these 2 other points are so I know where to start and stop my integrations. And then I'm going to label these top and bottom. So this is arbitrary x, and this is x over 16. This guy is arbitrary x and 3 plus the square root of x. This one still has the same bottom, x over 16, but a different top, x comma 4 over the square root of x. How do I figure out these guys? Well, I want to set this and this equal to each other to figure out that intersection point. So I got 3 plus the square root of x equals 4 over the square root of x. So we'll multiply by the square root of x everywhere. And then I can set this up as a quadratic. Actually factor that. So looks like that, which tells me that x equals 16 or x equals 1. So Yeah, I guess this thing, if I go far enough out, this thing will still be there. There'll be a point out here at 16, but I don't want that one. I want the one that's here at 1. So that's at 1, 4, right? Put 1 into here, you get 4. You put 1 into here, you get 4. So we've got 1, 4 is there. And then to find this one, we're going to set 4 over the square root of x equal to x over 16. We get 64 equals x to the 3 halves. So take the cube root, you get 4 equals x to the 1 half, and then you get 16. So I guess I didn't have to go that far out, but I get 16. If I put 16 in there, I get 1 out. Okay. That's weird. That's not actually a root. Okay. Because I want that to be minus 4, right? Square root can't be minus 4. That's not good. So that one, which is good because we didn't use that one anyway. Okay. So I'm still trying to find this entire area. So I'm going to find the left half first, and that's going to be the integral from 0 to 1, because my orange rectangles on the left stop at this point, which is at 1, 4, right? So 0 to 1, and then I'm going to take the integral of the top curve, which is 3 plus the square root of x, minus the bottom curve, which is x over 16. And then I will add to that the integral from 1 up to 16 of, I'll take the top curve again, which is in this case 4 over the square root of x, minus the bottom curve, which is still x over 16. And add those two together. So I would get 3x plus x to the 3 halves divided by 3 halves, which is the same thing as multiplying by 2/3, minus x squared over 32. That's going to be evaluated at 0 and 1. Plus, we're going to evaluate 4x to the 1 half divided by 1 half minus x squared over 32. And this one's evaluated at 1 and at 16. Plug in 0 here, you get 0, 0, and 0. So I plug in 1, I get 3 plus 2/3 minus 1/32. Plus, that's actually an 8, right? X to the 1 half minus x squared over 32 at 1 and 16. So 3 and, well, let's put this all in terms of 96ths. So that'd be 288. Is that right? 96 times 3. Yeah, 288. Plus, that's 96 plus 2/3 of that would be 64. 96 minus 3/96. Here we'll finish that arithmetic off after I expand this. I put 16 in, I get 32. Square root of 16 is 4. 4 times 8 is 32 minus 16 squared over 32. So one of those 16s cancels with the 32 to become a 2 down in the denominator. The other 16 will turn into 8 when I divide it by that leftover 2. That's 8. And then I have to take away evaluation at 1. So evaluate this at 1, I get 8. And then I'll add that 1 over 32 in because I've subtracted it there. So I might not have needed to go all the way to 96 because those guys are going to cancel. That's 16. So this is 16. So I've got 3 2/3 plus 16, 19 2/3, which is 59 thirds. Okay, questions on that one? There's kind of a lot to it. Other questions you guys have?
Can I ask, is our test on Wednesday or is it tomorrow?
On Wednesday.
Okay, thank you.
Anything else you guys want to talk about?
Can I ask about it's a different section,
Sure.
but just I have like 2 questions over a couple different concepts in different sections.
Sure. Which section? Which question?
5.1, but it's in like the study plan. Well, the specific questions are. Then like all chapters. Like on number 15 and 16, I think it's just that last one.
Just either one of those?
Yeah. So like 15 and 16 and the actual like.
Oh, sorry. Okay.
No, it's fine.
Probably a faster way to do this, but Okay, so we've got a circle. First, we're going to put a square inside. And we know that that is 1. And that's 1. We know that this is 90 degrees because it's broken up into 4 sides, right? So each side gets 360 by whatever. So the length of the side here is going to be well, let me do it this way where I split straight down the middle, and then I have a better trig picture that generalizes. Okay, so you flip the picture over, you get this triangle here. So this is S over 2. We get S over 2 equals the opposite over the hypotenuse, which is the sine of 45 in this case. Good with that?
Yep.
Okay. And so that's the square root of 2 over 2. S is the square root of 2, so the area equals S squared. That's one way we can do this, would be 2. Okay, let's do the octagon now. Terrible sketch, but we're going to focus on the left again. So I get a picture. Triangle like this, where this is 1 as the hypotenuse again. This is S over 2. This angle that's 2 pi. I've broken it up into 8 triangles, right? And I'm taking half of one of those, so this is 2 pi over 16, or pi over 4, pi over 8, right? And what we can do is I can take the 16 triangles, each of them looks like this. So I've got 16 times S over 2 times, we're going to call this H, times H times 1/2, because this is the area of one of the triangles and I've got 16 of them all together. Does that make sense?
Yes, but aren't there only 8 triangles?
There's 8 big triangles, but there's 16 of them that look like this.
Oh, okay.
Yeah. So that's going to be 4 times S times H, which is 4 times, well, S, again, S over 2 is the sine of pi over 8. H is the cosine of pi over 8. Let's use S over 2 and put an 8 here. Make things easier. So this is 8 times sine of pi over 8 cosine pi over 8, which is 4 times 2 sine pi over 8 cosine pi over 8. 2 sine cosine, that's your double angle for the sine. So that's 4 sine pi over 4. So that's 4 times the sine of pi over 4 is square root of 2 over 2. So 2 square root of 2. It wants a decimal rounded to 3 decimal places. 1.4 times 2, 2.828 probably. Okay. We get to do the same thing with the 16 gone again. Everything in here stays the same, right? Except for my angle here, right? And then the number of triangles increases. Those things are going to increase. So let's do this again. We've got 16 little triangles this time. This is going to be pi over 32. So S over 2 equals sine of pi over 32. H equals cosine pi over 32. And I have 64 of these things. Which by that double angle identity is going to be 32 times the sine of pi over 16. Why did I say 64 of those things? I have 32 of those things, right? Yeah. So I should get 16 sine pi over 16. Good with that?
Yep.
Okay. Which that's going to round to something close to pi. I could do this with ends. We're going to put 16 in there. Let's get a calculator. That's not radians, is it? Okay. I'm gonna delete those. Okay. There we go. Pi divided by 16. That's the number of radians that I want. Sine of that is that. I'll multiply that by 16. That's not right. Why is it dividing it by 16 again? I don't know how to use this. This isn't a nice calculator. So we'll multiply it by 16. And then we'll multiply it by 16 again because it seems to have divided by 16 an extra time right there. And that's close to pi. 3.121. Okay. We'll type this in someplace else. Three 3.121 still. Any ideas? If I do I'm not sure what rounding we weren't doing right. Or maybe I'd done a 32 gon instead of a 16 gon. So I'll have 32 of these little triangles, which turns that height and that width, sorry, that side length and that. So S over 2 is the sine of pi over 32. H is the cosine of pi over 32, so you take 2 of those. That times 16. You got a factor of n screwed up somewhere, or a factor of 2. Yeah, I was doing a 32 gun. 2 pi divided by 32 is pi over 16. So I had a factor of 2 missing in 2 spots, which was not good. So I want 1/2 times s over 2 times h times 32. So that's 16 times sine of pi of 16 cosine pi of 16, which is 8 times the sine of pi over 8. And I bet that's the 3.061. 8 sine pi over 8. Yeah, 3.061. So, okay. I was missing a couple factors of 2 and 1/2. So this is n over 2 and 2 there. Still is pi. Okay. Where do we have questions on that one?
I think it was just like, yeah, setting that up for,
Okay.
yeah, being able to do it for more of them.
Yeah. Kind of making it in a generalized form is, yeah, kind of key on that one. Is the other one similar? Okay, let's try this one too. Two times the sine of x on 0 to pi. Well, that looks like this. This seems like a computer type problem. I think the T means technology probably, especially since it says use technology to perform the following steps.
Okay.
So let's just pull up Wolfram Alpha again. And so I want to find the average function value over these rectangles. So I have 100 rectangles. So I've got 1 over 100 is going to be the base, the denominator of my average. And then I'm going to multiply that by the sum. And I'm going to take the sum at the midpoints of those rectangles. So the sum is going to be of 2 times the sine of, well, x sub I. I'm going to fill in x sub I later, comma, I equals 1 to 100. Okay, so if I add those up and then I divide by 100, that's going to be the average function, the average value of those 100 values. Does that make sense? And the midpoint, well, I'm going to start at 0 plus like half of the width of a rectangle. And each rectangle, the whole thing's pi wide. So this is going to be pi over 100 is the width of one rectangle. So pi over 200 is half the width of the rectangle. So that's where I start. And then for the ith rectangle, I'm going to add pi over 100 times I. Maybe I shouldn't use I because that might think it's a complex number. So I'm going to put n in here. And I think that should give me what I want. We'll see how it interprets it. So it says it's going to sum it from n equals 1 to 100, which is what I want. And then I'm going to have the half bit plus how many rectangles away I am, full width, and I get this. Okay, so it does that. And it gives you the expanded forms. If I wanted to approximate it, let's just put in a decimal so it approximates it. So 0.01 times that. And maybe it'll approximate it, 1.27. I've only got 5 decimals, so somehow I need to get more decimals in here. I don't remember how we got more decimals, do you guys? Let's pull Excel up. You can do this in Excel too. Didn't it just tell me I could do pi? P, capital PI maybe, no? Yeah, let's put it in as a function. Okay. And then here we're gonna add divided by 100. We're gonna carry that down to 100 spots. Yeah, so that'll be the last midpoint. That one's outside the bound, so I don't want that one. Okay. And then we will 2 sine of this. That's going to give me my function value. And I'll drag that down so it does that, gives me that function value for each of these points. And if I look down here, I get the average. clear down here at the bottom. So the average of those cells, there's 100 cells there. It's going to be 1.2732919, whatever. So I can put that over here. 292 to average it up. Okay. We can do the same thing with 200. I'm out of time today, so here you'd put a 4. Here you'd put a 2. And we're just going to drag that down until I get to 200. And I can drag down my evaluate the function at. And then I want the average of B1 to B200. And you'd use that number. And then you could do the same thing with 500. Okay. I'll end it there though. And I will see you guys tomorrow.